Here we go, guys. Second videos. We're going to be working on special right triangles and also what radians are. However, before we begin, this was the problem that I left off that I'm sure you were wondering, when are we going to actually do that? We're going to do it right now. Given y equals 5, 6x is the terminal side in quadrant 3, we want to find all 6 trig functions. So, terminal side, I'll show you what that means in a second. 5, 6x means that we have a slope. We're going up 5 for every 6. So we went up 5. We can also go down 5 because we are in quadrant 3. Down 5, and we went over 6 in the negative direction. The terminal side means that, let me get a little arrow here, the terminal side means this part is where we ended. And that's important because we're not talking about this angle that's closest to the y-axis. We're talking about this angle closest to the x-axis. And that angle is going to be called alpha. So, let's go ahead and find the 6 trig functions. Sine of alpha. Let's actually find the hypotenuse first, and I think we found in the last video is root 11. That's my mistake. We'll find the hypotenuse, we'll do Pythagorean theorem, is negative 6 squared plus negative 5 squared, and that's equal to z squared. We got 36 plus 25. And that looks like that's going to be equal to 61, which means our hypotenuse is going to be the root of 61. So, finally, sine alpha. That's going to be negative root 5 over 61. I'm sorry, negative 5 over root 61. Cosine alpha. That's going to be negative 6 over root 61. Tan alpha. Again, opposite over adjacent. That's going to be 5 over 6. And here's your reciprocal trig functions. Now, you may be wondering why the negative stays at the top. If you are, remember the fraction is just going to be one full number. The negative implies that that number will be negative once the division is done. There's your 6 trig functions of alpha. Let's proceed on to the content in this video. A radian. It's a common way to measure angles in trigonometry and calculus. In physics, you'll actually use degrees quite a bit. And we'll warn you in class, Ms. Schwartz and I, that if you have both physics and calculus this year, you'll be reminded to switch your calculator from radians to degrees, degrees to radians, etc. A radian is established by taking the length of a circle's given arc, which we'll denote as s, and dividing it by the radius r. So theta is equal to s over r. This little formula is not going to be used at all really in calculus, but I want you to know what a radian is. Positive radian implies counterclockwise rotation, so in this order. A negative radian is going to be implying going backwards, clockwise rotation. It's interesting that we say clockwise is backwards, but let's not get lost in some semantics. How it works. So let's say you're given a circle whose radius is 12 centimeters, and I'll draw a picture here. The radius is 12 centimeters, and we'll say that the arc length, however, I don't know where exactly this angle is, but we'll say the arc length here is 4 pi. Now, I want to know what a radian is. Well, the radian is going to be found in this following manner. I know that the entire circle, all the way around, is going to be 2 pi r. 2 pi times r, which is 12, is going to give me 24 pi. But I only have 4 pi. So how much is the 4 pi out of the 24 pi? Well, that looks like it's going to be 1/6. So I have 1/6 of the circle total. Now, if I know I have 1/6 of the circle, now 1/6 of a circle is going to be 1/6 of 360 degrees, which is exactly 60 degrees. So this angle that's opening up is 60 degrees. Now, if I remember my conversion ratio to radians, 60 degrees times 1 times pi over 180 gets me pi over 3. So 60 degrees and pi over 3 are going to be the same measurement. This little formula I'm going to show you in a little bit. I know that I haven't shown it to you yet. Now, interestingly, I could have bypassed all this work and just done 4 pi, the arc length, and divided it by the radius. And when I take this value, 4 pi divided by 12, that also simplifies to pi over 3. So a radian can be found by taking the arc length and dividing it by the radius. Now, in a lot of the work that we're going to do, the radius is going to be 1. Here's a formula that I was using to go from radians to degrees or degrees to radians. If you remember dimensional analysis, just make sure you're canceling the term that you want to be left with. Make sure you're canceling a term so you're left with the unit of measurement that you're interested in. So if I want degrees, I want to make sure my radians cancel. For every 180 degrees, there's a pi radians. And that's worth a picture. 180 degrees is worth pi radians. It's the same unit. You can pause the video here to see the degrees to radians. Okay, so now we're interested in how many degrees is 1 radian. Well, 1 radian is going to be the same as if we take 180 degrees and compare it to pi radians. The radians cancel, and now we have 180 over pi degrees, and if we calculate that, we're going to end up getting 57.295 degrees. Sketch 1 radian. Okay, so that means that the circle is going to open up about 57.295 degrees, which is approximately 1 radian. So we sketched 1 radian, we found out how many degrees 1 radian is. Now, let's determine the radius of an arbitrary circle whose arc length is 10. So here I have a circle, I have an arc length of 10, and I'm going to erase that picture because that's misleading. I have an arc length of 10, and I know that the rotation is 1 radian, and I need to find my radius. Well, I know that if I divide my arc length by my radius, I should get 1 radian. Solving that, I end up getting that 10 has to be my radius. Go ahead and convert the following to radians. Pause the video, resume when you're ready to go. Okay, hopefully you got these. 0 degrees will be 0 radians. And I should have you note also here that 360 degrees will be the same as 2 pi radians. 30 degrees, 45 degrees, all the rest are there. Hopefully you got them correct. And again, if you were having difficulty, I would have taken the number of degrees that you had and multiplied it times pi over 180 degrees. Okay, special right triangles. This is going to be a little bit of a review, and I hope that you don't find it too bad. I'll start with the smallest side, which is always opposite the smallest angle. In a 30, 60, 90 triangle, and you've seen this before, in a 30, 60, 90 triangle, the hypotenuse is always going to be 2 times the smallest side. The side in between the hypotenuse and the smallest side is going to be root 3 times the smallest side. For the 45, 45, 90. If I start with x, and I know it's an isosceles triangle, so I know that my height is x. I know this is an isosceles triangle because I have 2 angles congruent. Then I could just use Pythagorean theorem here to solve for the hypotenuse. So if I get 2x squared is equal to z squared. and I want to solve for z, then I'm going to take the square root of both sides, and I'm going to get z is equal to root 2 times x, or x root 2. You'll want to remember these, and if not, you'll want to remember how to get the work that I just did. Okay, so I'm going to go and label these here. This is x, this is 2x, this is root 3 times x. Over here we have x, and we have root 2 times x. The sine of 60 degrees, that's going to be opposite over hypotenuse. If you pause the video and plug this into the calculator, making sure your calculator is in degree mode, you will get a long decimal, and if you type root 3 over 2 into your calculator, the decimals will match. Your cosine of 60 degrees. Well, we have adjacent over hypotenuse. That's going to be 1/2. A tangent of 60 degrees will be opposite over adjacent, which is going to be equal to root 3. A secant of 60 degrees is going to be the reciprocal. The sine of 45 degrees is going to be x over x root 2, which means it's going to be equal to 1 over root 2, or the more popular root 2 over 2. I will warn you here that, again, 1 over root 2 will probably be better, as we'll be doing a lot of reciprocals. The cotangent of 45 degrees is going to be opposite over adjacent, which is really just going to be 1. Okay, so now your next task is going to be to take what we just did and write them in radian notation. And you can see I already have the first 3 here to demonstrate for you. I'm going to write D, E, and F in radians as well. And then pause it and resume the video when you're ready to go. Okay, hopefully you got those answers. And that's the end of video 2. We're almost there, guys.